So hope you're doing great. So I'm here to present an article on the title called Advancing Heart Disease Prognosis with a Hybrid Mission and Deep Learning Approach. And I'm happy to say that this work was done, with with a group. It's a group actually. It's a group, but it's a group consists of two people, one from Saudi and US, Saudi, and the other one from it's me, from United Arab Emirates. And honestly speaking, we have done, we have spent roughly 8 months for this work, and we are really obliged and happy to see that our paper has been accepted in a prestigious conference like this. Okay, so getting into the context, uh, so what is the reason for this research? Why we have to do that, and what is the motivation behind that? Like heart disease is one of the leading cause of the global deaths. So as per the stats, it says like roughly 17 million people annually were affected by this heart disease. So what we thought is, so if we try to bring some early or some diagnosis, that definitely could save lives. So that was the reason to work on this. So this research involves something called EMR. Okay. So it's nothing but the electronic medical records, which usually help to detect the patterns. So what we have done is we have just worked on identifying the patterns so that it could help to it could help to predict the early diagnosis. Right? And this is our problem statement. Okay, so what we have done is, number one is we have worked on a concept called overfitting, right? Okay, and high dimensional data. So usually the problem with the existing model is that, when it comes to prediction models, they suffer a lot because of overfitting, and they have the data which has more classes, like the dimension of the data might be high. So what we thought is we we proposed a new feature. It's kind of an optimal feature to improve the model efficiency. And finally, thankfully, we were able to predict patient survival using a technique which is called a hybrid learning technique. So by the way, when the presentation goes on, I will be telling you what is mean by hybrid, right? This is a research objective. So what we have done is we have developed a hybrid model which usually combines the ML, machine learning, and the deep learning, right? And we have integrated a feature called CSFB, but in short, I will be telling you and showing you the framework of how it looks and how it works. And the main objective is to integrate CSFB feature selection so that the data processing could be optimized. So what is the benefit out of that? So once we do that, we could improve the accuracy, precision, and also the interpretability of the heart diseases. This is the significance of our study. Okay, so we thought that once this is done, this is of course, and obviously obviously this is going to support clinicians to diagnose the early patient prognosis. This is one thing. And the next thing is that even we thought this this study may enhance the reliability of the survival predictions. Yes, and also we strongly believe that this will improve the healthcare outcomes because we have used AI techniques, right, through our insights. Okay, and we have done some literature review about ML approaches. I don't want to bore you much about this to talking about this. So what we have done is we have analyzed on few things like the common algorithms. What are the common algorithms? This was our main aim. So how these algorithms were used, what were the problems, and where this algorithm fits and where it will not fit, and what is the reason behind that, right? So we have analyzed each and every algorithm in multi dimensions. and the next analysis goes on between, I mean, like about the accuracies, like, okay, so when you usually when you talk about the model, the accuracy is pretty important. Yes, of course I agree. Precision, recall, specificity, sensitivity, like ROC curve, these are very important. But like for initially we thought of working on accuracy, so that drives our interest. And that's the reason why we have analyzed only few papers that ranges between 84 to 94%, because we don't want to waste our time by analyzing the papers which gives you less accuracy. I mean, like the accuracy which is less than 84. Right. And also we have analyzed a couple of papers that talks about the features. That's a redundant features. It means that if for example, like let's say like the features which can be used common, why, and the risk of overfitting also. So these were our concerns, and this is what we have studied in our literature review. Yes. And also, as I told you in the beginning, like the goal is to do a hybrid stuff. So when it comes to hybrid stuff, we have made a small thing like to integrate how to use ML with DL. Right. So you need to study about the existing ML algorithms, and as well as you need to study the existing DL approaches as well. So from the slide, you could see these are the deep learning models which we have studied. We have studied about DNN in, like CNN and RNN. Okay. And also, and the whole world knows that the deep learning is effective for large data sets. But the problem is it's computationally intense. It's intense. Yes, of course, it's intensive. So that's the reason we thought, okay, so based on our literature study, we thought that we need some kind of optimized feature selection so that we can balance between the accuracy and the efficiency. And you could see this is a research gap, and this is what we have found in the literature review. Like, there are few studies usually which merges the ML and DL with optimized feature selection. That was one thing which which is the main key of this interest. And the next thing is that, like there were limited research focuses, yes, on the patient survival prediction rather than the detection. For example, like, don't take me wrong, okay, let's say if the patient is suffering from X disease, so for example, can you tell me like how long this patient is going to survive? No one can say this. So that's the main thing. So why can't we work on the survival rather than the detection? That was our concern. Okay, so that's the reason we propose something called hybrid CSFB and CMD model for the survival analysis, and I will be showing you the architecture. And okay, and this is our framework. So what we're going to do is, so our input is pretty simple. So as folks very well, like this is a prototype. Okay, we have developed a prototype, and we are and now we are moving this prototype to the next level. So that's what we are working on. So I cannot show you the prototype now, but like I can give you the overall framework. I'm sorry for that. Right. So the input initially what we have taken is this, the heart failure clinical record data set from the UCI, because initially, as it's a prototype, as it's for the presentation, what we thought, I mean, like this, we have just used the secondary source of data. Okay, now we are working on the primary source of data. We are trying to get permission from the relevant health authorities. We are, so now we are doing this research in a full-fledged, so that we want to develop this prototype into a product. That's our main goal. Okay, so once the data is obtained, okay, so we are going to work on the feature selection. So the first feature selection which we are going to use is nothing but CSFB. What is the CSFB? And you all know about the feature selection algorithm, but the trick is we are going to use both sequential forward and backward. That's okay. That's the trick. So that's the unique. Sorry to say this, it's not a trick, it's a unique. It's a unique because, you know, like why I'm telling you the trick, because when we start this research, we were doing trial and errors. So we were like integrating the algorithms, we were like doing like hardcore programming. Then what we thought is, okay, so why can't we try with X and Y? Why can't we try with X and Z, Y and Z? So it was kind of a honestly speaking, it is a kind of a combination and combination. This is what we have been trying, and we were like working for I mean like worked for a day and night, right? Okay, then after that we worked on the classification, of course. Yes, because, you know, like at the end, you know, like at the end, the objective is the binary classification, because, you know, like here we are not going to talk about the multi classification, because as I said you in the earlier stuffs, that binary classification, because the person is going to survive or not. So obviously the answer could be yes or no. So the feature should be like yes or no. So we have trained our model in, I mean, like in the way of two classes, like either yes or no. That's it. So for that, we have just combined ML and DL, machine learning and deep learning approaches. And finally, the output could be like survival prediction. That's it. And even we have, and even our accuracy seems to be very good. I mean, the model accuracy, right? Yes. So these are the data set description. This is the data. Okay, as I mentioned before, like as for the prototype, we have used the secondary source from the UCA repository. That's it. So this is the data set, and out of that, you know, the data consists of 299 patients and 115 females and 194 males, and the ages are from 40 to 95, right? And apart from that, we analyze 13 features, okay, that could be physical and lifestyle as well. And finally, as I said, is yes, this research work focus on binary classification, either 0 or 1. So the class 0 says survived and 1 says deceased, right? Okay, and coming back to the point, okay, you could ask me like why you have integrated the forward and backward. Yes, we have a point on that, and we have the proof of this, and this is the proof. Okay, so once we combine this, what happened initially was it helps us to reduce the dimensionality, and also it enhances the model accuracy. So this technique helps us to select the optimal features. For example, let's say you take a data set which consists of have like 50 to 100 features. So the problem is, how would you know like these features are the best features? How would you know that these features are the optimal features? For example, on the go, if you are selecting a feature that may not give you the best result for your model, so the question is, how do you select the feature? Based on what? Based on what analysis? This was the question which was running in our mind. That's the reason we are very keen to work on this feature selection. So by using this algorithm, we are pretty much sure that this algorithm helps to select the best and optimal features for your model. Yes. That's it. It's simple. Then I have told you we are not going to use the plain classification algorithm. Instead of that, you know, we have used something called CMD. So what is the CMD? It's very simple. Okay, C is a combination. M is art terminology, please. Okay, so ML is nothing but MLC. In our research, we have, you know, like SVM, KNN, RF, and DL. So we have combined all these algorithms. That's it. So we have just combined all these algorithms. So what we have done is we have implemented something called, okay, stacking, assemble. You have heard about ensemble learning. Yes, same. Yeah. So we have used something called stacking assemble, where we usually have, we have analyzed about base learners and meta classifiers, right? And even, you know, like first we try to execute with a no code platform, like, you know, we have used Veka platform. That's it for the experimentation. And this is what we have done. As I told you, first we will be doing pre-processing, then, you know, like feature selection, then you can ask me, like, usually feature selection comes under data pre-processing, but why do you keep this as a model? So so in our case, when it comes to deep processing, I'm literally talking about the data cleaning. Yes, because we are not talking about data analysis, we are talking about the data cleaning, which is very important. Because let's say if I have a data set which is not cleaned with which is with I mean, like, which is not cleaned, and if it has NaN value, so how does I process the data set? And let's say if the data set has a class imbalance problem, how would I fit this? So that's the reason we thought, like, we need to do a pre-processing, which is like a pretty much essential step for any AI models, right? And step 2 is a feature selection, and step 3 is classification, and finally we have evaluated this. And you could see this is how it works. So initially the data set is given, and it goes to the feature selection, then the optimal features are selected, then it goes to the model, right? You can see, then it goes to the model, then this model will be reduced, the dimensions, the features will be reduced, and again this is used as a training data set. And now for the training, I'm using 3 models. It is SVM, KNN, and RFF. And once this is trained, and we call this as level 1 predictions. We call this as level 1 predictions. Then after that, it goes to the level 2 predictions. See this by using a deep learning. Then finally, then finally we get a result which is a binary classification, either like a 0 survived or 1 or deceased, yes or no. That's it. So, you know, these are the sample algorithms. This is a sample. It's a pseudocode. You can call it as a pseudocode algorithm, right? That's it. Okay. So we have written this as, I'm pretty sorry, this looks, it's a mathematical model. So as you're experts, you know about this. And see this, and we know very well. So first thing is to work on confusion matrix. Yes, we worked on confusion matrix so that we can work on true positive, true negative, false positive, and false negative as well. And also we have analyzed the metrics, accuracy, precision, recall, and F measure. Yes. And you could see, like, this is the confusion matrix, and this is the algorithms accuracy. Yes. So our algorithm CMD, the last one, so it's managed to get more than 90%, which we were pretty happy about this. And you could see the recall. This recall outstands all other models. And even you can see the F measure. This F measure is comparatively better than the other existing benchmark models. So this is the comparison of our algorithm, with the benchmarking existing ones. And you could see that when it comes to accuracy, sorry, okay, sorry for slip, okay, my job. So SVM, you know, like SVM produces 69.8, whereas KNN 74, random for 75, and you know, like, we were very happy by seeing this, because our model can able to produce 99.3, which initially we didn't believe this. Initially, we didn't believe this, and we thought that how could a model can produce 99% accuracy, which is impossible, right? But you know, like, we tried with different data sets, and this is the highest, and the lowest which we have got is 97. Okay, this is what. And precision, yes, and our precision is very good, because it's 9.78. okay, it's 9.78. yes, and you can see this recall, it's 9.1, and it's 9.89. so overall we are happy with this performance. So finally, I would like to say this, these are our findings. So we would like to say the feature selection is pretty important, because our model performs based on the features. That's it. And finally, I would like to conclude that we have proposed this model, which which has achieved roughly 99% of accuracy, and our model helps us to minimize the data dimensionality as well. And we personally trust that, okay, this is going to improve the reliability of the diagnosis, especially the early diagnosis. And also we foresee that this research, if it's taken forward, so maybe this could be a game changer. So But this is what I want to discuss. Like, even though the problem is that now we are struggling with this, because like, if you want to get, because we are going to use the human data, which is pretty sensitive. I'm talking about the primary source, folks, right? So what we have to do is, so we need to talk to a couple of people. We need to get the proper like proper proper permission, so-called permissions. So we are okay, so we are working on that. And next thing is that, when it comes to CMD, of course it requires high computation and memory resources, not like quantum obviously, but still it but still it needs resources. And also I have this I like our team have this in our mind too. Why can't we develop some enhanced CMD for the time space? Because now the problem is the time, right? Okay, so as even though this model produce a good results, but the problem with this model is it's taking time, it's consuming little, like it's consuming more time than expected time. Even for us, for a computer scientist, nanoseconds matters a lot, right? So that's it. So these are the references. So thank you for the opportunity given. So now please, I would like to have a brainstorming. If you have anything on your mind, please. Thank you.